but they did allow for a timely escape. Regarding communications, the German army used short and long-range radios with varying levels of encryption. Important signals were sent via the Enigma system, which used internal rotors to change the letters of the message. It was configured differently each day. Although initially seemingly indecipherable, the Allies later managed to break the code. For tactical use, vehicles carried smaller radios. Tanks had internal intercoms and external antennas. Platoons could speak to their commanders using handheld devices, although their range was limited. The sound quality depended on the area, the weather, and interference. Throughout the war, electronic warfare became increasingly important. It wasn't just firepower that counted, but also the ability to see first, detect first, or confuse the enemy. Germany started with an advantage in this area, but the Allies soon followed suit with advances of their own. Fritz X, Mistel, and H-293, the bombs that Germany controlled by remote control. One of the Luftwaffe's most advanced ideas during World War II was to guide bombs from an airplane toward a moving target. Until then, bombs had been dropped by eye, from a height, with luck or calculation, but with no possibility of correcting their direction once they were in the air. What German technicians proposed was to be able to move the bomb as it fell, to make it more precise. The first serious model was the Fritz X, a bomb very similar to a standard 1,400 kilogram bomb, but with small cross-shaped wings and a tail section with movable surfaces. The device was released from a fairly high altitude and controlled by the aircraft's gunner with a kind of remote, like a joystick, which sent signals by radio. To track the bomb, the tail was painted white, and the operator observed it through an optical sight. By moving the control, he could correct its path if it went off course. It was a primitive system, but it worked. The first time it was used successfully was in September 1943, when they sank the Roma, an Italian battleship that was sailing to North Africa after signing its surrender to the Allies. Another guided bomb was the HS-293, which was lighter but incorporated a small rocket motor that ignited after being released. This gave it greater horizontal range and allowed it to fly toward its target almost like an airplane. Like the Fritz X, it was also controlled by radio signals from the launching aircraft. The operator guided it remotely to the target, especially enemy ships at sea. The HS-293 was used several times against Allied convoys, especially in the English Channel and the Atlantic. The British, realizing that it was radio-guided, attempted to jam the signal with electronic jamming. This reduced its effectiveness, but did not completely eliminate it. Several vessels were damaged or sunk by these weapons. There was another, even stranger system, called Mistel, which consisted of joining two planes, a large one below, loaded with a huge bomb in the nose, and a small one above that, guided. The pilot sat in the top position, and when they were close to the target, he released the bomb plane, which crashed and exploded with a brutal payload. It was used to attack bridges, ships, and fortifications. These three types of guided bombs demonstrated that Germany was far ahead in ideas that are commonplace today. Although they were cumbersome and difficult to use, they showed that the concept of guided missiles was already in place before the war ended. Despite this, the impact of these weapons was significant. The sinking of the Roma caused by a Fritz X was a clear example of their potential. On other occasions, entire convoys had to change course or suspend operations because they knew the area was dangerous for this type of attack. The Mistel, on the other hand, was more complicated to use. As the smaller aircraft was unmanned and packed with explosives, any failure in the docking or guidance system could cause it to veer off course. It was also difficult to hide such a large aircraft, so it wasn't ideal for surprise attacks. But even so, there were successful missions, especially against bridges and reinforced positions. Nazi jets, the planes that arrived too early. One of Germany's greatest technical achievements during the war was putting a jet-powered fighter plane into the air. The Allies were also working on this, but the Germans were the first to truly achieve it. The model that made the difference was the Messerschmitt Me-262, a twin-engine fighter that flew much faster than any propeller-driven aircraft of its time. Jet engine development had begun before the war. In Germany, work was led by the Heinkel and Junkers companies, which focused on finding a way to use high-pressure gases to spin a turbine and generate thrust. At first, the task was difficult. Materials wore out quickly, parts overheated, and tests frequently failed. But little by little, they solved the problems. The first German aircraft to fly with a jet engine was the Heinkel He-178 in August 1939. It was a small experimental aircraft built solely to prove that the system worked. Later came the Heinkel He-280, also with twin jet engines, which flew well but was never used in combat because the Luftwaffe decided to invest in Messerschmitt's project. The Me-262 began to take shape in 1940, although it wasn't until 1942 that it was truly successful in flight. Initially, problems with the engines continued. They broke down quickly, lasted only 20 hours of use, and required constant maintenance. Even so, it was the fastest aircraft in the world at the time. It exceeded 850 kilometers per hour, which was impossible for any propeller-driven fighter. It had 4 cannons in the nose and could easily destroy bombers. Besides the Me-262, there were other interesting jet aircraft. The Arado R-234 was the world's first jet bomber. It used 2 wing-mounted engines and could fly so high and fast that it was almost impossible to intercept. It was used for reconnaissance missions and also to drop bombs, albeit in small numbers. There was also the Horton-Ho 229 project, a flying wing-shaped aircraft with no fuselage or tail. It was intended as a low-radar fighter, although it never made it past the testing stage. The design was so advanced that decades later it served as a damned-eye inspiration for stealth aircraft. The Me-262 was not only fast, it was also stable, easy to maneuver, and had plenty of power to shoot down heavy bombers. When it dove from above, it was nearly impossible for an enemy aircraft to avoid it. Pilots flying conventional fighters couldn't keep up. But while it had many advantages, it also had limitations. One of them was that the engines took a long time to react when the pilot accelerated. This made takeoff and landing difficult. Furthermore, if the plane moved abruptly, the engines could shut down automatically. Because the interior materials wore easily, the engines only lasted a few dozen hours before needing to be replaced. Despite everything, the Me-262 saw combat in 1944. It attacked in small groups and managed to do a lot of damage, especially against Allied bombers. But it was too late. Although the plane was far superior in technology, there weren't enough trained pilots or fuel to take full advantage of it. The Arado R-234 also flew real-life missions, primarily for aerial photography. At first it didn't have normal landing gear, but a detachable carriage that was released after takeoff and landed on skids. Later, retractable wheels were added so it could operate from conventional runways. This bomber was fast, but it couldn't carry many bombs, and its drop accuracy wasn't very good. However, it served to show that jet aircraft could have uses beyond direct combat. The Horton-Ho 229, although not completed in time for combat, was one of the most striking designs. Its bat-wing-like shape made it difficult to detect by radar. Only a few prototypes were built, and one of them was taken to the United States after the war for study. All these models confirmed that Germany had fully entered the jet age. Although its aircraft didn't change the course of the conflict, they paved the way for what would come next. The fighters, bombers, and spy planes that would fly in the following decades would borrow many ideas from those early German prototypes. Impossible prototypes. The strangest ideas of the Third Reich Germany didn't just work on conventional weapons. It also greenlit a long list of experimental projects, ranging from the logical to the completely bizarre. Many remained as initial drawings or tests, but they reflected an interest in seeking unusual solutions to a conflict that was dragging on longer than expected. Among these projects was the Bar 349 Natter, a very unusual aircraft that took off vertically from a tower. It was designed to be flown directly into a formation of enemy bombers by a single pilot. It had solid fuel rockets for climbing, a main engine that ignited mid-air, and a detachable cockpit so the pilot could bail out after firing his payload. In theory, it was reusable, but in practice only one flew with a pilot on board, and it ended in a crash. Another curious design was the DFS-346, a rocket plane with thin wings designed to fly at speeds close to Mach 2. It was developed with the help of data collected by test pilot Lippisch. The aircraft was launched from another aircraft in the air and then fired its rocket engine to reach high altitudes. It never entered service, although the idea was revived by the Soviet Union after the war. There were also studies on flying wings, armed gliders, and rocket-powered fighters. The Me-163 Comet was one of the few used in combat. It was small, bullet-shaped, and used hypergolic fuel that exploded on contact. It climbed extremely rapidly and could reach over 900 kilometers per hour, 560 miles per hour, but it only had a few minutes of endurance. After attacking, it glided to the ground, where it was very vulnerable. Despite its speed, the Me-163 was not very successful. Its engine was dangerous, the landing difficult, and the attacks ineffective, as firing at high speed without stabilization did not guarantee hitting the target. Many pilots died due to system failures or landing accidents. Another unusual invention was the Skoda Kauba SKP-14, a kind of winged manned torpedo boat that used a ramjet engine and was designed for suicide missions. It never made it past the prototype stage, but it showed the desperation with which new ideas were sought. There were also proposals for enormous bombers such as the Yonkers Ju-390, which was a stretched version of the Ju-290 and could in theory fly to America and back. Only a few examples were built for testing. Within the same group of strange ideas was the Flugzeugträger Graf Zeppelin, an aircraft carrier that Germany began to build but never finished. Despite advances in naval engineering, the project was cancelled several times and ultimately fell unused. Germany had no real experience with naval operations of this type, and its priority was elsewhere: submarines and air defense. As for submarines, new ideas were also being considered. Type 21 U-boats were designed, which could remain submerged longer thanks.
Watch what milk does to your eyes.
Batteries and a more hydrodynamic hull shape. Although they arrived late to the war, they paved the way for modern submarines. Some were captured intact and studied by the United States and the Soviet Union. There were also experiments with surface-to-air missiles, such as the Wasserfall, which used technology similar to the V-2 but was smaller in size. The idea was that it could intercept enemy bombers from the ground. The missile had radio guidance but was never used operationally. The project fell by the wayside, although it served as the basis for anti-aircraft missiles in subsequent decades. The effort to develop new weapons was enormous, but also chaotic. Many projects overlapped, funding was lacking, and information wasn't always shared between teams. Time pressures and constant bombing raids on factories and facilities further hampered progress. When the war ended, the Allies found an archive full of sketches, models, engines, and half-built parts. All of this was collected and taken to different countries for analysis. Many of these ideas, which seemed fanciful at the time, were later successfully revived. Although most of these prototypes never saw combat, they demonstrated a radical approach to military innovation. Rather than improving what already existed, they sought entirely different paths. The perfect soldier, weapons and personal equipment ahead of their time. Throughout the conflict, many new handguns were designed and manufactured, seeking greater power, accuracy, and ease of use. One of the most important was the Sturmgewehr 44, which can be considered the world's first assault rifle. This weapon combined the rapid-fire capability of a machine gun with the maneuverability of a rifle. It fired intermediate chamber ammunition, allowing for better control when firing bursts. It was shorter than a traditional rifle and more effective in close-quarters combat. The design of the STG-44 was a direct response to the needs of the Eastern Front, where soldiers faced enemies at close range, often in urban or forest environments. The army needed a weapon that offered a greater volume of fire than a standard rifle, but without the weight and recoil of a full machine gun. In addition to the STG-44, other personal weapons were developed. For example, the MP-40, an automatic submachine gun with a straight magazine and folding stock, was widely used by assault troops and paratroopers. Although not as accurate at long range, it performed well in close quarters. Another innovation was the use of portable grenade launchers like the Panzerfaust. This was a disposable tube that fired a hollow charge capable of penetrating the armor of Allied tanks. It It required no complex training. A private could use it with little instruction. The Panzerschreck, on the other hand, was larger, reloadable, and had a protective shield, but served a similar purpose. Hand mines, adhesive charges, special knives, and various types of grenades, such as the classic handle grenade, which is easier to throw, were also designed. Rifles with telescopic sights for snipers and models specifically designed for use in snow, desert, or wet environments were produced. Germany even explored silent weapons with pistols equipped with suppressors and subsonic bullets. This type of equipment was used by special units, spies, or sabotage missions behind enemy lines. Although limited in number, it demonstrated the extent to which all types of scenarios were considered. In addition to weapons, research was also conducted to improve the equipment worn by soldiers. Uniforms designed for different climates were introduced with fabrics resistant to extreme cold or moisture. The Waffen-SS, for example, used camouflage uniforms, something uncommon in other armies of the time. These designs sought to better conceal combatants in wooded or snowy environments. Experimental night vision goggles were also developed. The system used infrared light reflected by a spotlight, which was captured by a special lens. These goggles were large and heavy and were only mounted on vehicles or fixed weapons. Even so, they were a preview of what would later become common. Panther tanks even tested this equipment in night combat, albeit in very limited numbers. Programs were implemented to improve individual first aid kits, providing soldiers with painkillers, adhesive bandages, and basic treatments for infections. Helmets were also modernized, using molded steel with improved shock absorption. The German helmet design was so practical that many countries copied its shape years later. Another aspect of the advancement was in communication. Smaller portable radios were introduced for squads, allowing for better coordination of movements. There were also headsets for tankers and artillery operators. Although rudimentary compared to those of today, they were superior to those used by other armies at that time. German paratroopers, the Fallschirmjäger, received specific equipment. They wore cut-off helmets, knee pads, and compact weapons like the FG-42, a combination of an automatic rifle and a light machine gun, designed especially for them. This model allowed firing from the shoulder or in a prone position and had a folding bayonet. Drugs were even explored to keep soldiers awake or improve their resistance to fatigue. Some troops were given methamphetamine pills to endure long marches without sleep. Although this had serious side effects, at the time it was seen as a temporary solution to maintain momentum at the front. The combination of technical innovation and war pressure led Germany to develop, within a few years, a wide variety of personal combat tools. Although many did not change the outcome of the conflict, several influenced how a modern soldier is armed and equipped. Midget submarines and suicide weapons, Hitler's latest naval gambles. In the final stages of the war, Germany began testing one-man marine craft. One of the first was the Neger, which was really nothing more than a modified torpedo. It had the same shape as a standard G7E torpedo, but on top was an acrylic cockpit where the pilot sat while lying down. That pilot used a simple periscope to guide the vehicle, and his only mission was to approach an enemy vessel, aim as best he could, and then release the real torpedo, which was mounted just below. There was no way to exit if the craft failed or became trapped. This model was battery-powered, and its range was very limited. It also had no real protection against nearby gunfire or explosions. What made it useful was that it could approach silently and attack by surprise. Although many pilots were killed on the missions, some managed to sink small ships. The idea was to use it as a human torpedo, though without the operator directly crashing into it. Next came the Marder, an improvement on the Neger. It had the same base, but could dive a few meters, giving it more options for approaching undetected. It was also electric and operated with very simple controls. It had no re-entry equipment, so the pilot knew his life was at risk from the moment he emerged. Another device was the Molch, more like a miniature submarine. It measured about 8 meters and had an elongated shape. It was completely underwater, although very close to the surface. It was operated by a single person and armed with 2 live torpedoes in the front. Its range was short and its maneuverability limited, making it very difficult to use in waters with currents or active defenses. The Molchs were used primarily in the Mediterranean, and although they were designed for large-scale operations, the results were poor. Many missed their targets or were destroyed before firing. Even so, dozens were manufactured because the German command wanted to try every possible means to stop Allied convoys. And in parallel, the Biber, another slightly more sophisticated midget submarine, was built. This one already had room for 2 people, although only one person was almost always present. It had a small diesel engine for surface travel and an electric one for underwater navigation. Unlike the Molch, the Biber could dive deeper and travel longer distances. It also carried 2 torpedoes on its sides. Its weakness was that it often leaked water, and visibility from the cockpit was almost zero. The Bibers were launched from coastal ports to attack ships near England and in the English Channel. But as with the other models, the success rate was very low. Some sank before reaching the port, others were detected by radar, and several went off course and ran out of fuel. The design of these weapons showed a mix of desperation and creativity. They were developed in a short time, using recycled parts or adapted from other aircraft. Their military utility was limited, but they represented a form of unconventional warfare that Germany attempted to exploit in the final years of the conflict. The attacks were coordinated by special units, often using tugs or motherships to bring the small submarines closer to the target. The missions were carried out at night, with no communication with base and with minimal instructions. Although these models were far from comparable to traditional large U-boats, they were much cheaper, easier to produce, and didn't require large crews. In theory, they could operate in areas where normal U-boats couldn't access, such as Allied ports or landing sites. But of the hundreds of devices launched, only a few managed to hit any target. The Nazi command maintained these operations until the last year, hoping that they would at least delay the Allied advances. Another device tested during those same years was the Linzer launch, a small motorboat designed for strike missions against enemy ships.